Welcome, my dear students, to the next part of the chapter Periodic Classification of Element. Here in this chapter, we will be going to learn how the modern periodic table came into existence. Before we going to start with the modern periodic table, I would like to make a small revision with respect to the previous lecture which we have taken. In the previous lecture, it was understood classification of element was done mainly by three scientists, Dobereiner, Newland and Mendeleev. We remember Dobereiner had tried type of classification where he considered the atomic masses, average of that. Newland had octave type of classification where he considered 8 elements, and the 8th one and the first one will share the similar properties. And Dmitry Mendeleev, a Russian scientist, also developed a very much effective classification technique where we understood the elements can be classified according to their atomic masses. And the main merit of the classification of element according to Mendeleev, it was he can even predict the elements which are yet to be discovered. Even though classification of elements was much more successful because of Mendeleev periodic table, but still it holds lot of demerit as well as demerit. So we have to understand how it was overcome by execution of modern periodic table. Let us find out. Students, on your screen you will be able to see the modern periodic table of elements. Before going to start with the modern periodic table, I would like to put some light on how it came into existence. The scientists in the world had a limited knowledge with respect to atom when Dmitry Mendeleev made his periodic table with respect to elements' atomic masses. After the discovery of electron, scientists started exploring various atoms, and they understood electron number of an atom and atomic number are actually a different thing. The atomic number in the Mendeleev periodic table only indicate the serial number of the element, only the serial number. But in short, atomic number was referring lot of properties of an element. So almost like in earlier 20th century, with the discovery of X-ray and X-ray tube, scientific world was able to find out atomic number of a particular element correctly. This revealed that atomic number is more fundamental property of an atom other than atomic mass. So they understood atomic number is much more fundamental, much more proper fundamental property with respect to atomic mass. So the property of elements are periodic function of their atomic numbers. This is a statement. We can say it as a law. You will able to find this in your textbook, page number 20. Property of elements are periodic function of their atomic numbers. So once they understood atomic number is a fundamental part, so now they try to arrange these elements according to atomic number. So as it was solving the puzzle of various demerits of Mendeleev periodic table, it was able to understand how we can correctly classify these elements with respect to modern periodic table. Right now we are seeing in your screen. So the classification of elements resulting from arrangement of elements is an increasing order of atomic number. They just take the atomic number of particular element, all the elements, and they started to arrange it according to the increasing order of the atomic number. In the modern periodic table, the elements are arranged in accordance with the atomic number, as you are able to see that. As a result, most of the drawbacks, okay, that's the main point. Most of the drawbacks of Mendeleev periodic table was able to remove. We have seen that previous standard, that electronic configuration of atom, the way which electron are distributed in a shell and all, we have already learned. But still, I'll also explain you how it is, how the electrons are arranged in a particular shell in an atom in the coming part of this video. So this was very much important when we understood that it was very much fairly, they clearly classified them according to the atomic number. But still there was a problem. But still there was a small problem, that was with respect to hydrogen. So that about that position of hydrogen is not removed even the modern periodic table. Like the problem was not even removed. Okay. So as you know, hydrogen had both the properties. So and the previous video also I told you, hydrogen, because of that ambiguity, it was not able to fit properly in a correct periodic table. But still they managed to arrange a space for hydrogen. Now let us focus on the structure of modern periodic table. The structure of modern periodic table consists of mainly 7 rows called as periods. You will be able to find out 7. Look on the screen, I'll show you 1 2 3 4 5 6 7. So this 7 is actually rows. We refer them as periods. 7 1 2 3 4 5 6 7. So we have got 7 periods over here. So 7 periods. Similarly, we have got 18 vertical columns in the table group. They are called as groups. So the vertically we call them as groups, and horizontal one we call them as periods. So apart from these 7 rows, 2 rows are also shown separately. We'll be able to find out 2 rows are exclusively separately shown in here. So these rows are lanthanide series and actinide series. Start from lanthanum, cerium, praseodymium, neodymium. That is having atomic number from 57 to 71 here over here. And we've got actinide series over here. So we are going to learn about all this in the next part of this video also. So before starting, we just make you understand we have got 7 periods, we have got 18 groups. So look at color classification over here. The red one, this one is alkali metals. Okay, here we have got alkaline earth metals. We have got transition metals over here. So transition metals are over here. All the scandium, titanium from this 21 from here, all this part. The entire this color is called transition metals, and alkaline earth metals are these. Post transition metals are these. We've got metalloids, and we've got non-metals over here. Actually, we consider this as non-metals. So non-metals. So these are metals and these are non-metals. In between, we got a zigzag line. Okay, can you see a zigzag type of pattern over here? They have the properties of metal as well as non-metal. That's why we call them as metalloids. And here you got halogens: fluorine, chlorine, bromine, iodine. So these are the halogens, and we have got noble gases also. Okay, which have the complete octet. They do not take part in any of the chemical reaction, as in, so they are called as noble gas. So this was generally the structure of our periodic, that is modern periodic table. Here you're able to see this is a symbol. Okay, this is a demonstration over here. This is a symbol. Let us take hydrogen as a example, where H is a symbol of an element 1, which represents atomic number. Here we have got a valency over here, and this is the atomic mass. So atomic mass can be in decimals. Atomic mass can be in decimals, but atomic number never can be in decimals. It's a number of electron, number of protons present in an atom. So it was very much fairly logically correct to classify the periodic table according to atomic number. So all of you. I hope you understood this part. Let us move on to the next part of this chapter. Here we will able to same thing it is, but we have arranged them in their blocks, in different type of blocks. We call as, like you will able to see this S block. We have got a P block over here. We have got a D block, and we have got a F block. The lanthanum and actin ICTs, we have got these blocks. So and in total we have got 118 elements at present with respect to modern periodic table. Many of these elements are recently found out, almost like within after 2000. We have found out many elements we have got, but as of now we have got 118 elements in our modern periodic table. So the entire periodic table we can divide it into 4 groups, as I already told you: S block, P block, D block, and F block. The S block contains group 1 and 2. You can able to see that S block contains group 1 and 2. Group 13 to 18 constitute of P block. Okay, group 18 to 13 constitute of P block. Group 3 to 12 constitute of D block. Okay, so 13 to 18 P block, and 3 to 12 we have got D block over here. And the lanthanum and actin series separately we call them as F block. I hope you understood that. Okay, so one more thing we have understood. There's one more thing. We have got a zigzag line over here. Okay, the zigzag pattern. Can you see this zigzag pattern? That is actually elements which have both the properties of metals as well as non-metals. Clear with respect to that? Okay. So students, as we have already done with respect to periods and groups, so it was very much understood there was some relation between atomic number and the classification of these elements. So within the period, the neighboring element differs slightly in their properties, while distant element differ widely with respect to. There was difference, like lot of difference. Neighboring wala, thoda bahut, it was almost they have similar properties, but the far away ones had a very different properties at all. So elements in the same group show similarity and gradation in their property. Very carefully, elements in the same group shows similarities. So these characters of the group and period in the modern periodic table are because of electronic configuration of the elements. So exactly, electronic configuration is very much close to atomic number. So the arrangement of electrons, electronic configuration plays a key role in this. So it is the electronic configuration element which decides the group and the period in which it has to be placed. So I've already told you. So if you look at, we have got 7 periods and 18 groups. Accordingly, we have also classified them according to the alkali metals, earth metal, and so on. I already told you hydrogen had a problem with this. That's why we cannot fit it over here. Even though hydrogen is non-metal, it cannot fit over here. Actually supposed to be fit over here, but since the atomic number is 1, according to the modern periodic table, atomic number will always be at first. So that's why only hydrogen is being separately arranged over here. So it comes under non-metals, but still it comes under S block. So I hope you understood how it works on. So let us try some relation. Actually, let us learn some relation between groups. Okay, the 18 groups. Okay, we got 18 groups. So 18 groups and the electronic configuration, how it works on. Okay, so systematically, if we learn about these things, it will be like proper arrangement of periodic table of the elements. So I would like to tell you, we find the number of valence electron in all these elements from group 1, that is that family of alkali metals, like number of valence electron. That is what do you mean by valence electrons? The number of electrons which is at the outermost shell of a atom. So this is known as a valence electron. So look at group number 1. We got hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So all these elements which belong to group number 1 have valency of 1. Similarly, if you look the elements from any other group, we'll find the number of valency of valence electron to be same. Like valence electron, not valency, valence electron. For example, element beryllium, magnesium, calcium belong to second group. That is the family of alkaline earth metals. So what will be the outermost number of how many will be the number of outermost electrons in the outermost shell? There are 2 electrons. Since they have got 2 electrons in the outermost shell, they actually belong to the group number 2. So isn't it fantastic? So it is in the same way. When you take it any like halogen we have got fluorine, chlorine. So they come under 17 group. That is the family of halogen. While going from top with any group, one electronic shell gets added at the time. Okay, clearly you have understood this part. So there are two electrons in the outermost shell of group number 2, so accordingly it is set. Similarly, there are 7 electrons in the outermost shell of fluorine, chlorine and halogen, the group number 7. So that is the family of halogen. As you know, halogen have electronic configuration like similar to, if it is 17, it's 2, 8, 7. So that is the family of halogen. While going from top to bottom within the group, okay, within the group from top to bottom, from upper se leke niche, top to bottom, one electronic shell gets added at that time. From this we can say that electronic configuration of outermost shell is characteristic of particular group. If you say group, so that will be the electron that have a proper direct connection with electronic configuration of a particular element. However, as we go down a group, the number of shell goes on increasing. However, we go down in the group, the number of, as it goes on, as you know, as it goes on, the number of shell goes on increasing. So one more example I would like to show it to you. Let us consider this titanium. We have got good number 4. So number of, we have got 22 is the atomic number. So what will be the configuration? That outermost shell we have got 4 electrons. That's why come under group number 4. So it works in a very same way. So you have to understand how it works on. Okay, I hope you understood this part. Groups of electronic configuration, groups and electronic configuration, how the relation goes on over here. So let us learn about the next part, that is period and electronic configuration, how it is been connected to each other. As you know, in the previous standard also we have learned about the electronic shell K, L, M and so on. So here we are going to discuss how it works on over here with respect to period and electronic configuration. Let us take example of potassium, okay, or sodium, anything. Okay, let us take group 1. Okay, group 1, we got 18 groups, we got group 1, and let us take period 4. That is, we have got potassium. Group 1, period 4. Group 1 and period 4, we have got potassium over here. The electronic configuration of potassium is 2, 8, 8, 1. 2, 8, 8, 1. So how many electron shell are there? 1, 2, 3, 4. Since we have got 4 shells, therefore it belongs to 4th period. Since we have got 4th period. Now let us take on this argon 2, 8, 8. Since we have got 3 shells, okay, to occupy the electrons in argon, so it comes into belong to 3rd period. The same way with respect to helium or hydrogen, anything. 1, 1, 1, 1. So on with respect to these. Since they have got 5 shells, since they got 5 shells, that's why they belong to 5 shells to occupy their electrons. Therefore, they belong to the 5th group. That is the relation between period and electronic configuration over here. So as you also know, electron capacity of electron shell also, we have learned this in the previous standard also. So K will have 2 electron capacity and L will have 8 and M will have 18 electron capacity. But very carefully you have to understand, but if you have a confusion, like we write, for example, in the previous example we had an example of potassium with electronic configuration 2, 8, 8, 1, where it should supposed to be 2, 8, 9, since according to this rule, but the rule is actually different over here, which I would like to tell you. As per the electron holding capacity of shell, 2 elements are present in the first period and 8 elements are present in the 2nd period. So the third period also contains eight elements due to the law of electron octet. So there are few more factors which control the filling of electrons. So it is due to the electron octet rule, the third shell will have 8 electrons, even though the maximum capacity of this shell is 18. But according to this electron octet rule, we have got 8 electrons maximum over here. The chemical reactivity of an element is determined by the number of valence electron in it, and the shell and the valence shell. The information of these points are obtained from the position of the element in the periodic table. That is a modern periodic table as. That's why it is much more proved. This modern periodic table have proved much more efficient with respect to this. So there are few more factors which controls the filling of electrons, which you will be learning in the next higher standards, in your higher standards, not in this in this syllabus we don't have that part. Okay, I hope you understood the entire lecture. If you have any doubt, please comment it. I will be very happy to help you people. That's all. We will continue in the next lecture. Thank you, my dear children. Take care.